So we're live. Hello everyone. We welcome to our JagBD virtual meetup. Today we have a great Oracle Evangelist, Elder Moraes. He is a great speaker and he's going to talk about containers. Hi, Elders. How are you doing, man?
How are you, man? So I would like to thank you very much for inviting me and to having me here. It's a huge pleasure. Welcome to everyone that is watching us live and for all people that will watch later.
Okay, thank you for joining us and for your time. And for the viewers, you can watch this session. And if you have any question in the YouTube section, there will be an option to ask questions. So you will take questions afterwards. What do you think, Elias? After
Okay.
your after the session, we will take your
After
questions, and if we have some times, we'll able to talk about Java EE as well. So let's begin.
Okay. Yeah, as Bosler said, we can talk a little about Java E and maybe E4J in the end of the talk. So I'm also writing a book about Java E8. It's Java E
Perfect.
quick book. Yeah. Maybe it will be available in January or February. But
That's great news.
It's already on pre-order in Amazon and Packet. That is our publisher.
Okay, perfect.
Okay, so can we start?
Yeah, let's start.
Okay, so I will share my screen.
Sure.
And we'll put my presentation here. Can you see my presentation?
Yes, we can see.
Okay. So guys, welcome again. And today we are going to talk a little about containers, Java E, and clouds. And this is a talk that I gave with my friend Bruno Souza. I'm sure that many of you already know him. And we gave this talk at JavaOne like a month ago. And so here we share our Twitter, and this talk it's based on some articles that I've put on my website that you can see down the slide, eldermoraes.com/articles. It's a series of articles that we published on OTN, Oracle Technology Network, and there you can see all the concepts, the code, and the GitHub links and so on. Okay, so I like to start talking about containers using this architecture. For those who never saw this picture before, this is the Java EE architecture. Okay, since the Sun times, its picture never changed so much, and you can see that even the core of the architecture of the Java EE, we have containers. If you look at the picture, you can see the applet container, you can see the web container, you can see the EGB container, you can see the application client container. So all the architecture of the framework, the platform of Java EE is based on containers. And the best thing that we can take from these containers in the core architecture of Java EE is that Java gave to us a very cool stuff that we call packaging. Okay, so once we have packaging, because in the technologies that we had before Java, packaging was a very a huge problem, a huge issue, because you don't have a packaging pattern. Okay, so you have some server, and you had a folder full of files, and you deploy those folders full of files on those servers, and you have many issues trying to to deploy and to update. And if you have some problem in production, you go there and change the file. So you have many versions problems without the packaging feature. So once we have the packaging feature, and in Java we can use jar files, war files, ER files, we have a standard, because the standard gave to us the possibility of having a package that we can use to deploy our artifacts, our applications, our systems, and so on. And when you talk about Java EE and containers in Java EE and the packaging standard, we are really talking about standards, okay? Because once we have a standard for our application, and in our case, our example, I'm using Java EE to talk about, I know that I can code my application relying on standards, okay? So I don't have to put on my application, for example, I don't have to code my request life cycle, my response life cycle, how I will manage my queue, how I will manage my connection with database, because I can rely on a standard that is already implemented on my Java EE server. Okay, uh, of course I can do it. I can do a fetch jar and do whatever I want in my application, but uh, it's very good. It's very funny. It's very reliable that I can count on a standard that is already implemented on my Java EE server. And this kind of feature allows us to have many Java EE servers. So we have WebFly, WebLogic, Tommy, Glassfish, WebSphere, Payara, and many others. And what's the point here? The point is that once I have my application coded for Java EE standard, I can deploy it in any of the Java EE servers, compatible servers. Okay, we should remember that Java EE is a certification. Okay, so for you to build a Java EE server and says that it is a Java EE server, it should pass on a certification. Okay, in this certification, it's an implementation of a specification, and it is a standard. So the point is that now your application that relies on a pattern, we say that your application is agnostic. Okay, so it shouldn't. It doesn't matter where the application is running, where the application is executed, because it is relying on a standard, and that it comes to you through the specifications, through the packaging, and through standards. Okay, and what the relationship between all the subjects that I'm talking here with Docker, with containers? Okay, because Docker is also a standard for containers. And let me give you a little introduction about containers. I don't know how many of you already is trying Docker, is trying containers, is using containers in production, or even trying some demos on your laptop. But I'm sure that many even you guys that never tried containers before, never tried Docker before, I am sure, and I will prove to you that you know everything about containers, okay? Because I know that all of you have, many of you maybe at least have refrigerator, okay, on your house. And I'm sure that if you have a refrigerator on your house, you store food on your refrigerator, and you use some cases that here in Brazil we call Tupperware. Okay, I don't know if it's a common name for you guys, but it's a case, okay, that you use to store food on your refrigerator. And why we use Tupperware. Why we use those cases to store food on our refrigerator? We use it for isolation, okay, so the food doesn't mix with each other. We use it for the smelling of the different foods doesn't mix with each other. It doesn't make one food to taste bad or smell bad. Okay, we use it to so we can make a stack of those cases. Okay, so we can increase the density of our refrigerator, because if we don't have those cases, those containers, we wouldn't be able to stack all those cases. Okay, so we can also use those cases to protect, okay, against the humidity, against the temperature and whatever. So all those concepts are valid for containers in the industry software. Okay, so we use containers to isolate the containers, to protect, for safety, for security, for density. So again, for people that are not familiar with containers, uh, think about containers like a kind of virtualization. Okay, I'm sure that all of you already tried any virtual machine like VirtualBox, Vim, and whatever. This is a virtual machine. Okay, a container is a kind of virtual machine. It's not a virtual machine, okay, because it's much leaner, it's much lightweight. You don't have that kind of isolation from the host that we have on virtual machines in containers. So containers are made for sharing much more resources with its host than any other virtualization. So, but the point is, the same case that I told before with application servers that brings the standard, and now you can rely your application on the standard implemented on the Java server. We had on containers in another, think about it in another abstraction level, okay? So our server is an abstraction level. Now our container is not another abstraction level. And what the point for it? The point is, we had historically many problems between two roles in companies that are developing software. We had the developers guys and the operations guys. Okay, so the developer guys is the guys who are coding, who are doing new features, doing new applications, new systems. And the operations guys is those guys who are keeping those applications running, keeping it available, keeping it safe, secure, and so on. So what's the conflict between those roles? The conflict is that anytime that a developer wants to improve the application, to put a new feature, or to update the version that is running in production, it's a risk for operations guys to application stays unavailable for seconds, for minutes, for hours, for a day, or whatever, depends on the problems that they have. So we have those situations. Imagine that Basilur comes to the operations guys at his company, says, "Oh, look, I have here this application. It's Java. Okay, I just learned. Just an example. I learned Java, and I have this application, and I want to put it on production." And the operation guy look at this application. Oh, okay, Java. It's to run. It's Java /jar, and okay, I can run it. Okay, I can run it. I can stop it. I can do a backup. That's okay. Java, it's okay, and the system, the application is now in production. And 2 months later, Basilur go back to the operations guy, said, look, remember Java? Now we have Java E, and I have this new application, and I want to put it on production. And the operations guy look at, well, Java is Java. Yeah, we can start, we can stop, we can do backup, and okay, let's do Java E. And 2 months later, Bosler come back to the operations guy and said, well, now I have a PHP application. This new application, it's cool, and we have some cool features here, and I want to put it into production, okay? And the operations guy is not liking so much, but well, PHP, it's Apache. Apache, well, seems like Java server. Okay, I can stop, I can start, I can do backup, and okay, let's do PHP. And 2 months later, Buzzword come back and say, well, man, I have here this Ruby application, and the operations guy just cut your speeches and say, well, stop it right now. I learned Java, I learned Java E, I learned PHP, I will not learn Ruby, okay? So I will standardize right now. You guys are going to use just JavaOne and with WebLogic Q1, and we'll standardize it, and no updates anymore, and you go back to your desk and live with that, okay? So this is a conflict of interest. But if we really look at the situation, the both guys have reason here. The both guys are just trying to do the best with what they have. And when Docker comes here to give a great interface for those guys, because when now with Docker, with containers, the developer doesn't need to give to the operations guys an application. He can give to him a container, okay? A container that has the application inside of it. And the operation guy just will take that container and put on production and start and stop and do backup and recovery and put it on the cloud and change the cloud and run in a bare metal or whatever. And now this interface will make it easier to do all those processes. And because if you think about it on the port, when you have those big containers, and the guy in the port managing all those containers, he doesn't care on what is inside of those containers, because he will just put here and put there and change the chip and put on the port and take on the port and put on the chip. It doesn't matter what is inside. It's the same thing for Docker. It's the same thing for containers. It's a standard. And this standard will make it easier to do all those relationships in our industry. It's what we call DevOps, okay? DevOps container is great for DevOps because it will make it easier to all those roles to work again in peace and do what we do the best. That's improving our application, improving our systems, improving our software, and make it available, safe, and all the things that the operations guys do the best. And if you think about pipelines, maybe some guys can change some step or another, but most of our application has a kind of this pipeline. Okay, we code, we build, we test. Well, many don't test, but that's okay. And we deploy, and we have our infrastructure. And the good thing about Docker and containers is that we can use containers in all those steps for our pipeline. In a way, included that we can, if we think about automation, okay, because once we have our application inside a container, we can put it on a pipeline automated, so we can improve, we can have a huge improvement of our agility, of our our capacity of deliver the code faster and better. And if you think about you trying to convince your operations guy to move to containers, you can just put your software inside a container and you go to the operations guy and say, look, my application is inside a container. You can start, stop, and do whatever you do with all applications, just like the same way in whatever container you are holding. Why we don't automate our production with our application right here, and then we go back and do in the deploy environment, in the test environment, in the build environment, and then our code environment. So you can automate it and you can containerize your application in doing by steps and by environments. So all the stakeholders that are involved on the process in your environment can be convinced about the advantage of containers. So I will show you here right now a little demo. My first will be two demos, okay? My first demo is to show you a simple Java EE application that I will put it on containers and show you this. The end of the demo is this architecture, okay? It's 3 Tommy hosts running my application with one load balancer, one running Nginx load balancer, and a browser running the application. Okay, so and I will show you how easy and how fast we can take whatever application we have and put it inside containers and run in my machine right now. Okay, and when I was talking to you about refrigerator, I'm talking about density, that we can stack all those cases, all those containers inside my refrigerator. What I'm doing here is just like that. I'm running 4 containers for my application in a way that if you didn't have containers for doing that, we would need 4 machines or at least 4 virtual machines. And it's heavy, it's expensive. It costs a lot with CPU and RAM memory. So using containers, we can do it in a very lightweight way. Okay, so I will change now to my command line and show you my demo. So here, Boslor, the font size is okay. You can see.
We don't see your screen yet.
It's tiny. Better now?
You didn't share your screen yet.
I didn't share my screen?
Yeah.
Oh. Seriously?
No. You just this screen share just went off for now. So share it again, please.
Okay. Wow. but did you see my slides and so on?
Yeah, we did.
Okay.
Now you can went to demo.
Now you can see my command line.
No, we don't see your command line. We see the Hangout, the browser actually. Yeah, now we can see your command line.
Now?
Yes.
Yes. And you can see this list of files.
Yeah, we can see your command line now just.
Okay. So we'll go ahead. So guys, here is a couple of files that I prepared for this presentation. I have them on GitHub. You can go to that website that I mentioned on the beginning and take all those files and you can try it out on your laptop, in your house, and whatever. Okay, so what I will do here is take this is my application, okay, JavaOne.war. And I will take this application and put inside a container and run in my machine. Okay, so what I would like to show you for the beginning, for those who are not familiar with Docker, it's the file that it's our base for building containers. That is a Docker file. Okay,
Iler,
Docker file.
are you sharing your whole screen or just the terminal?
I'm sorry.
Are you sharing your whole screen or just the terminal? I mean, we can see your terminal just. Is that okay?
Okay. No, I was sharing the whole, but I will share again. Just let
Okay.
me.
Okay, you better just share the whole screen so that you will able to share anything.
What about now?
I don't see it yet.
I'm sharing the whole screen.
Okay, share it now again.
You can't see my.
I can see you, but I don't see your screen.
Wow.
Yeah, I can see your screen now. The browser actually. Okay, go ahead.
What about now?
I can see the browser of your screen. Can you open the terminal so that I can see it?
Yeah, I mean, it is also opened. I don't know if you.
I don't see your terminal yet.
Wow. Just, just a second. Stop again. Share. What about now?
It's not yet there.
Let me change it here.
Uh,
What about now?
I can see. Yeah, we can see now. Go ahead.
Now it's okay?
Okay.
Okay, so you can see my terminal, right?
Yeah, we can see your terminal now.
Okay. Sorry about that.
It's all right. It happens.
Yeah. So we have here a Docker file that is that's the file used for building containers. Okay. And the main points here is the from command that we use for if you never used Docker before. Docker has a cloud service that is called Docker Hub. On the Docker Hub, we have many millions, really millions of pre-built images for containers. If you remember that I said that you could think about containers as a kind of virtualization. It is a kind of virtualization, but it's not a real virtual machine. So you can rely on some pre-built images that I stored on the Docker Hub. So in my case here, I'm using a pre-built image that is done for Apache Tommy. Okay, so what I'm saying, Docker, is, hey, Docker, I will build a container right now, and it is based on Tommy and this version and this version. Okay, so I will rely on this pre-built, so I don't need to start from scratch to build my container. So what this file will build for me, it's an image, okay, an image for that it will be used to build containers. Okay, so I add my server.xml here to configure my to set up my my cluster. Okay, and I add some users, and here I add my war file. Okay, just like here. Okay, so the funny part here is that if we just change the war file, could be your war file, could be a jar file, whatever file that I used to deploy here, I could just build my image again and do another build another image with any any application, any Java application that we have. Okay, so what I will do right now is to okay, so I will run this command here. So I will say, hey Docker, build for me an image that I will name as Tommy UR, and I will give it to you an argument that is my WAR file, and you can find a Docker file just in the same folder that I'm working. So we build. So I have already my Docker image done here. Okay, so each line of my file, it's one step, and if we go here to Docker images, I have here my Tommy War that is built on my machine. Okay, so based on this Docker image, I can build containers. Okay, I don't have any container running right here right now. So now we can build containers. I will show you how we can build containers. So to build containers, you go to Docker and say, hey Docker, run for me a new container that I will name as host1, and the host name is also be host1. I will export the port 8080, and you will do it based on the Tommy or image. Okay, so and as we want to do a cluster, okay, a high available architecture, we will do it 3 times. So I will build a host 1, a host 2, a host 3, and I will export different ports so they don't mess up with each other. And no cluster is good enough if we don't have a load balancer, so I will build a load balancer in front of them so we can put all those containers together. Okay, so what I will do right now is run. First, it is dropping any containers that I have running before, and then all those hashes that we have here is the new containers that it's just created. And to check if they are running, we have here 4 containers. I have here the load balancer, and I have here 3 containers using my image Tommy War, and the IPs, the ports, and the names. And let's try our. We need to stop sharing and share another screen. Just the. You can see my browser, Pazlur. Hey, Pazlur.
I was mute. Yes, we can see your browser.
Okay, you can see the request is being answered by whatever.
Yeah, I can see that.
Okay, perfect. So this is my application running, okay? And once I refresh, you can notice that the IP is changing, the host name is changing, but the session ID is not changing. That's why I am doing a session clustering here, okay, using the load balancer, and all those 4 containers is running inside my machine. Okay, so what we just did here right now is, as I show you, I will stop doing my. I will share again. You can see my slides.
Not yet, but it takes a little time. Don't worry. You just go ahead.
Okay. If it doesn't show up, you tell me.
Okay, sure.
So what we just did here was to create this architecture using less than 10 lines of command, and we built 3 nodes for Tomei, 1 node for Nginx, and we have a whole architecture for uh, high availability here, using containers, using Docker. And I just take a Java application, put inside the containers, and start running them. Okay. So, so my application now is running inside containers. But what I want to do here is using containers not just for run my application, but also for automated my whole pipeline for my software. Okay, for this little software that I use it here, I want to automate it and using containers for it. So what I will build here, it's a CI environment, okay, a continuous integration environment. You can use many tools, many applications for it. What I choose here just to show you, it's any implementation of Git. Okay, it can be Git-Blit, GitHub, Bitbucket, GitLab, and whatever. We can use a Maven, okay, to do our build process. I don't know how many of you knows the Sonatype Nexus, but it is a binary repository. Okay, so once you build your application, you store on a Sonatype Nexus a binary repository, and you don't need to build that version again, and you can use that single build file, artifact file, and deploy it in any environment that you have. Okay, so here we have the development, Q&A, production environment. We use the same binary file, the same artifact file to deploy in all those environments. And we are going to use also Jenkins. I know that many of you already know it. And Jenkins is for those who are not familiar with that. It's I used to call it automator of anything, because it's really powerful. I worked on a project using Jenkins where we automated like 60 or 70 systems. Okay, not 16, it's really 60 systems. So we have many technologies. We have Windows, Mac OS, Linux, many distributions of Linux. We have Java, .NET, Android, iOS, and I don't know how many languages different we have, and we automated all of them using Jenkins. Okay, so first of all, we need to prepare our CI environment, and I'm going to do it using also containers. Okay, so I will share my screen again. Let's try. I will take my just to take a little note here. Okay. What I'm going to use here to build our environment, our CI environment, it's the Vagrant. I'm sure that many of you already know Vagrant. It's a provisioning tool that you can standardize the way that you create new machines, new environments, okay? And we are using it to build our CI environment. Just to give you a little picture of it, I will show the Vagrant file. File, okay. So what we are basically doing here, it's creating many containers, okay, for our infrastructure. I won't take too much details here because we don't have so much time. But basically, what we are going to use here is the Jenkins. Okay, so Jenkins is here, and Jenkins use also Postgre, and we have some other tools here. And here, the Vagrant file will run all. You take all the images that we will use for running containers, and here it will run the containers, and we'll pass all the stuff. And just to show you a cool feature for variants that is the providers. Okay, you can use many kind of providers to build a new environment, a new machine. Here we are going to use the VirtualBox provider. Okay, so basically it will create a new virtual machine on my machine to build my environment. But if we use another provider, for example, this one that is a managed service provider, I can connect to any machine on the cloud. Can be Oracle Cloud or whatever cloud that you know, and through SSH protocol, we can connect to those machines and run the same commands and provide our machine for our environment. Okay, so now what way? And the good part for Vagrant is that once you have the Vagrant file ready, you just run Vagrant up. Okay, and it will start to build my machine. I won't hold you here watching this screen because it takes a little time, like 30, 40 minutes, because it will download the base image and download the Docker and install all those containers, so it takes some time. So I won't let you wait here for that. But you can consider that with that Vagrant, I have my local pipeline automated using Vagrant. But and we can consider that this is my development environment. Okay, so now that I have my development environment automated, we can move to the cloud, and that's what I'm going to show you right now. First of all, I will take my application and move it to the cloud. Okay, so I have a machine on the cloud, on the Oracle Cloud, it's running, and I have prepared it for run my application. So I have here my files. Oops. And build. So this is exactly the same files that I show you on my machine, but now we are on the cloud on a machine that I prepared for show you. So I will do exactly the same process that I did in my machine. So I built the image and I run the containers. Okay, so it dropped the existing one, we create a new one, and we can check if the containers are running. They are running, and now we can go to the browser. Are you seeing my browser, Baslu?
Go ahead. Basically, it takes a little time. There is a delay in between you and me here. So you'll just go ahead. And if we don't see, we'll let you know.
Okay. So here's my browser. And the application, it's exactly the same application that I showed you before. And it's running with the same behavior and changing the host and changing the IP without changing the host name. Okay. So, well, my application was in my machine, automated it on my machine. Then I move my application to the cloud. Now I need to automate it on the cloud. So what I'm gonna do, it's take that exactly environment for automation that I built on my machine and build it on the cloud. So that Vagrant that is running on my machine and is still running and will take running for a while. I already did it on the cloud, and I can show you here many. Let me decrease the font just to show you. I have here couple of containers, maybe 15 or so. And we have here the Jenkins and the PHP and the Postgre. And what we have here, let me correct my share screen and the browser. I have here all those containers running on the cloud on that machine. And what I'm going to do here with Jenkins is use Jenkins to automate my pipeline on the cloud. Okay, so Jenkins is based on jobs. Okay, so I built here 2 jobs, one for Q&A environment and the other for production environment. I'm going to show you the Q&A environment. So that machine that is running my application, it's my Q&A environment. So what I'm just doing here is execute this job. And if I show you the output of my job is just the same command that I showed you in my machine. Okay, so now that my application that was on my machine, move it to the cloud, and now it's automated and it's still running. Okay, so I just use a Jenkins to deploy it on the cloud, and it's running. Okay, so if I want to do the same process for another machine, it's just a matter of create another job endpoint to a new machine. Okay, so let me back to my presentation. Slides. So what we did here was automated my development, automated my Q&A, automated my production, all those environments using containers. I'm using containers from end to end, since from my machine into the cloud. And that's what I was trying to show you. At the end of this presentation, I'll show you 2 projects. One project, I told you guys that I gave this presentation with my friend Bruno Souza, and I'm showing you a project from him that is called Code for Life, where he interviewed many guys, many experts from technology, and he also gives some career coach. It's worth it, really worth it of try it. So you can go to code4.life to try it. And I'm also showing you the Oracle Cloud trial where we gave $300 for you to try our cloud. So you can just go to that link or scan our QR code and try it. And Baslu, that's what I would like to talk. And thank you very much. And if you have any questions, I'm available.
Thank you, elders, for your time. It was a really great presentation and great talk. Hopefully, we'll entertain a few questions. In fact, I have a questions first, so I'll go ahead first. We have 2 containers right now. In popular containers. One is Docker and another is Kubernetes. So, what do you think about those 2 containers? I mean, why do you choose Kubernetes over Docker or Docker over Kubernetes?
Yeah, actually, Kubernetes is not exactly a container. Kubernetes is a solution for containers. You use Kubernetes to provision containers for orchestration, for you can scale up and scale down. Okay, so you can run Docker based on Kubernetes. Okay, they are complementary. They are not competitors or oppositors. Okay, so and talking about Kubernetes for me is the best solution that we have right now for containers, especially for orchestration. And it has many advantages. It's open source, and all the vendors are implementing Kubernetes right now. So you have Kubernetes running on the Oracle Cloud, on AWS, on Google Cloud. I'm not sure if Azure is also running Kubernetes, but I believe so. And so I really believe that Kubernetes it's the standard for orchestration, for provisioning of containers. Okay.
So we have another questions that is uh, we know you explained about Dockers containers. What are the benefits? Is there any drawback of containers based application? I mean, is there any? You
Sure,
explained a lot of pros. Is there any cons?
sure. Well, there's no silver bullet for anything, right?
Yeah.
You don't have any solution that is perfect for all the situations. Um Many people already did this that question for me, and for the kind of software that I work in until now, I still didn't find a situation where containers would not be good enough. Maybe a scenario is, well, if you think that containers it's a kind of virtualization, you can see it as a new layer for your infrastructure, for your network. And there are cases where you should reduce the layers and not increase the layers. Okay, so in some cases, maybe you should avoid to increment your layers. But to be very honest, never see a never saw a situation where I would say to you, well, man, don't use containers because it's not good enough. Because it's really help us to improve our agility, our availability, our communication between the dev and the operations guys. So I'm not. I can't say for sure a situation where I would not use containers.
Okay, so there is another question about cost comparison in terms of EC2. I mean, what would be, is it costly or is it cheap
About the cost, well, um,
compared to EC2?
Docker, yeah, Docker is free. Okay, so you can just download and use. You have now for since like 6 months ago, Docker has split the versions between Docker community and enterprise. Oh, yeah, it's a community version and enterprise version. Okay, so the enterprise version you have to pay for using. In the community version, you can use for free. The difference is some features that are proprietary for Docker. So most of the cases, I didn't see any company using the enterprise version. So the cost for using Docker is free. Okay, zero. The cost that you're going to have is for infrastructure. So if you have a server on the cloud, or if you have a server on your company, it's the same cost that you had before. But I believe that the cost will be very lower than in other solutions, because you can stack many containers in the same resources that you use to run just one web server or database or whatever. So I don't believe, I really know, I can assure that the cost you use it to run applications in the models that we had before will be cheaper if you use containers, because you can stack many containers in the same infrastructure.
All right, so let's take another question. Is there any specific standard or guideline for managing containers? Let's say in case I have hundreds of containers.
I'm sorry, I don't get the question. Can you
Okay,
repeat?
sure. Is there any specific standards or guidelines for managing containers. I can have
Okay.
hundreds of containers.
Well, it's like a kind of architecture question because you have many different scenarios for different solutions. So yeah, yes, you have good practice. Okay, so for example, you shouldn't store data inside the containers. You will store it outside the container. I didn't show you because we didn't have time, but it's a good practice. So yes, you have some guidelines, but again, we don't have silver bullets for architecture because
Uh, so basically, what you said, you don't store data in containers. That means we are not going to store database in containers, right?
you can run database in containers, but the data will be outside the container because the container is volatile. Okay,
Right.
if you drop the container, you lost any data that inside him. So you can store your data outside the container, but you run your container. Yes, your database in a container. You can do it.
Okay, perfect. So, okay, so we don't have any more questions. I have one questions about Java EE. In fact, we have a lot of junior developers in our community and freshers. They ask a lot about this question: Is Java is dying?
Man, I'm working with Java since 2002, so it's like 15 years right now. And since 2002 that I listen that Java is dying, that Java is dying, that I am dying, that everyone is dying.
Well, end of the
So
day, we are all dying, right?
yeah, yeah. Actually, it's true. We all are dying. But man, we are more active than before. This movement from Oracle to give the Java 8 to the community for open source, it was a huge movement, a huge move, and a huge thing for the community. So now all we developers and professionals can get involved with Java. And this version, this Java E8 and Java 9, that it was the first time in the history that we have both Java and Java E launched, released in the same day. So they are great releases for both technologies, and they are very mature. We have millions of developers around the world, so well we can say anything at least that we are dying, okay, because we are
Yeah,
very active.
there
I
are
mean, writing a
12
book.
million.
I mean, writing a book. I have many friends that also writing books for Java and Java E. So if this technology is dying, well, let's die.
Okay, so the last question I would ask about, tell about a little bit about moving Java EE to the Eclipse Foundation, and then we'll end up the talk. This
I
would be
don't.
your last question. So let's just tell a little bit about Java. Sorry, EE for J. I mean,
Okay, I don't think I get the question. What is the question?
so the question, it's not a question. I would rather ask you to give your comments about Java
Oh,
for the future Java E, as Oracle donated it to the Eclipse Foundation. So a lot of confusion there. People think Java is not Java is
okay.
not doing anything.
Yeah. Well, first of all, I believe that we should stop talking about the name, okay? Because the community is spending a lot of time, a lot of effort, and it was almost 2 months since the announcement, and we are still talking about the name. Okay, so we should stop talking about the name. The name is E4J, and we should move on and talk about the standards. We should talk about the next version. We should talk about how will happen the process of transferring all the intellectual property and all the code from Java E to Eclipse Foundation. So we have many important issues, many important topics that should be discussed, and we are still talking about the name. So what I believe, yeah, because if we blink, we pass a year and we are still talking about the name. You can look at the NetBeans. It was more than a year since the Oracle announced that it would be transferred to Apache, and still didn't finish. Oracle just transferred one block of code. What's up? Millions of lines of code, but it still didn't finish the transfer. So Java is very bigger. It's huge. It's a huge ecosystem. So if we spend so much time talking about the name and all those fightings, we really should we really could die in a year or two because it will stop. It will be freezing.
Okay, thank you, elders. You for your time all the way from the Brazil. We really appreciate your effort, and that's all for today. Hopefully, in the future, we'll invite you again, and you'll give another talk, right?
Sure, sure. My pleasure. Thank you very much for having me, inviting me. I know it's a weekend today, and it's late at night. So thank you for your patience, and hope you enjoyed. And I'm available. You can ping me on Twitter, Elder Java, also my email, elder.moraes@oracle.com.
Uh,
And I'm
can you
available
can
for
you
you guys.
can you share your slide for the last time, the your website and the uh, so that people can sign up to get
Sure,
resource from you. So basically,
sure.
elders doing did a great initiative about the next frontier. He is, if you sign up to his mailing list, he will send you a lot of content about Java EE and the up news and the other things he is doing. He's doing a lot of things parallelly. So hopefully you'll able to get a lot of resource.
Yeah, that's
Um,
it.
yeah. So
You can see.
no, we can not see yet. Uh, yeah,
Let
we
me
can see
see.
now. Yeah. You can get the link from the QR code and the link above. So there will be definitely a sign up for mailing list, and he will send a lot of contents, important contents, curated contents. Those are important for you. So that's all. Thank you, elders, for your time. We really appreciate it.
Thank you very much, Baslo. Have a great night.
Thank you. You.
Thank you.
So, elders, I have stopped the broadcast.